Okay, checkpoint 3.3. In figure 3.3, first of all, what is figure 3.3? Position versus time graphs for objects accelerating along a positive x-axis. Remember that if you've got position time graph that is looks like that, then our position is constant, meaning our velocity is 0. If you've got something like that, then our velocity, because our slope is constant, that's a negative slope, that's a positive slope. That means that our velocity, our average velocity, is also constant, but it's given by the slope, delta x, delta t. Okay? So that is a positive velocity, that's a negative velocity. But with these straight lines, you can see that the acceleration is 0, because acceleration is the second derivative of position time. It is your d2x dt squared. So if you draw the velocity time graph from here, you'll also get this one is going to be a positive velocity, constant. Okay, that's meant to be constant, and then that is negative. So I think we're clear about that. Okay, so that's going to be a negative velocity because it's a negative slope. That's a positive velocity because it's a positive slope. Okay, but then the acceleration is 0 because there's no slope. There's no there's no slope. There's no gradient for these two. Okay. So when do you get an acceleration? It is only when the position time curve graph is curved. There's some kind of curve, like here, curves. So that means that there is going to be an acceleration because you've got a curve. You've got the second derivative of your position time graph. Okay, I hope that makes sense. Alright, so it says, are the x components of the velocity represented by this curve positive or negative? Okay, so both A and B show that we're moving from a say a positive x value, a positive position, down to 0. A positive position down to 0. So both A and B show that our velocities are negative. I think that is pretty easy to see, and we can agree on that one. Okay? B, are the speeds increasing or decreasing? Okay, so note it says speed. It doesn't say velocity, it says speed. Speed is the magnitude of the velocity. It is independent of the direction, whether it's moving. So remember, our convention, we choose up as positive, down as negative. Okay? So, if it's moving up or down, we don't care because we're just looking at the magnitude of the velocity. So we can see, remember, velocity is delta x, delta t, and the delta x, okay, let's put it this way. If you are considering a time interval delta t, okay, and you measure measure the position between an initial time and a final time, a delta t. Okay, so you measure this, delta x is given by this vertical line, delta t is the horizontal, and we measure again later with the same time interval. Let's call it 0.1 second or 0.01 second. It is the same time interval. So over that time interval, you measure a delta x, and then you calculate delta x1 over delta t, and that is your v average 1, okay, which is your speed, okay, your speed, and then you do it again over here. You do it again here. You measure v average 2, which is delta x2 over exactly the same time interval. What you'll notice is that the speed is increasing. It's increasing because you have a larger distance that you've covered over the same time. You see that? Over that time period, delta x is that long. Over that time period, delta x is that long. So it is increasing in this one. Okay? It's increasing. Your speed is increasing. Alright? This one, as you can see, delta x is decreasing. Delta x over delta t is decreasing. That's my delta x decreasing. So my speed is increasing in this one, and it is decreasing in that one. Alright. C. This is getting interesting. Are the x components of delta v positive or negative? Okay, now we're talking about a vector. Delta v is a vector. Okay, so we know that the velocity, now we're talking vectors. In the previous one we were looking at speeds. Now we're looking at vectors. In the previous one, if we're looking at the velocity vectors, we saw that all of these vectors were pointing down, right? All of these vectors, whether in this graph or this graph, they're all pointing down because the velocity is from a positive position. It's pointed in this direction, okay? All our velocities are pointing down. So all our velocities are pointing in the negative direction. Let's start with that, okay? But we're not looking at our velocity, we're looking at delta velocity, the change in velocity. So let's draw this guy again. So at this point, we saw that our v, let's call it v initial, the velocity vector is down, pointing down, and it has a certain magnitude. Right, delta x over delta t. It has a certain magnitude. Then this one over here is also pointing down. Let's call that v final. And its magnitude is longer. It is bigger than the magnitude of that velocity. So we know that velocity delta v is v final minus v initial. Put in another way, v initial plus delta v is v final. I think that's easy to understand. Okay? So if so I'm looking for delta v. Is it positive or negative? So delta v is v final minus v initial. If my v final, okay, the magnitude of my v final is larger than that one. Let's draw it. Let's draw it using vectors. Okay, so I've got a small v initial, and my v final is bigger. So what vector do I need to put in here to get a larger v final? I need to put in that v delta v. So v initial plus v delta v is v final. Okay, so my delta v is going to be negative for A, and this is what it says here. Delta v points in the negative x direction in A. It points in the negative x direction in A. Let's go back. Let's look over here for this one. We see that our initial v, there's my initial v. I'm now looking at this one. Remember, our velocity changes from this magnitude to that magnitude. So my initial velocity is larger. My final velocity is it's pointing in the same direction, but it's smaller, which means that my delta v has to point up. Delta v has to point up. V initial plus delta v gives me my v final. Okay, so my delta v for this one is positive. Okay, so it says delta v points in the positive x direction in B. Does that make sense? I start off with a large velocity pointing in the negative direction. I end up with a smaller velocity pointing in the same direction. But my delta V, in order to move from this vector to that vector, I need a delta V that's pointing in the opposite direction, which is plus. Now D is related to this question. Are the x components of the acceleration positive or negative? So remember, acceleration is delta V over delta t. So because we're looking at vectors, my acceleration vector is always in the same direction as my delta V vector. So are the x components of the acceleration positive or negative? Well, in this case, the delta V was negative, so my x component in this case is negative. The x components are negative in A and positive in B. Negative in A, right, because my delta V is negative, and positive in B because my delta V is positive. The A vector always points in the same direction as delta B. Okay, so I hope that makes sense. Please give me some feedback if you don't understand anything.